Okay, warm good morning to my dear students and those who are listening this video. So myself, Professor L. Nagarajan, working as an assistant professor in the Department of Electric and Electronics Engineering, MAM School of Engineering, aggregated by NAC, approved by ICT, affiliated to Anna University. So today we are going to discuss about the biomedical instrumentation, basis of biomedical instrumentation, Unit 3. Okay, so let me go into the content directly. Unit 3, signal conditioning circuit. So in the past two units, Unit 1 and Unit 2, in Unit 1 we discussed about the biosignals alone, biopotentials. And in Unit 2, in Unit 2 we discussed about the measuring techniques and method of instruments that are used for the signal processing. And now actually what is happening inside the signal processor, that is very important. We have to know right now. So we are going to discuss about the signal conditioning circuits in Unit 3. So in this signal conditioning circuits, there are different amplifiers that we are utilizing, and these amplifiers are nothing but the operational amplifiers. Using these operational amplifiers, the different circuits are designed: differential, impedance matching, isolation, power line interference. So these are the different circuits that are designed using the op-amp. So how these circuits are utilized in the biomedical instrumentation, so everything we are going to discuss now. Right, need for bioamplifiers. What is the use of these bioamplifiers? Okay, so as I said earlier, the biosignals, biopotentials that we are getting from our body is in terms of millivolts. Okay, so what we have to do is we have to improve the level of the voltage for manipulation in the sense storing and display and data transmission, everything. Okay, so for this we need to improve the voltage level, we need to improve the quality of the biosignal. Okay, so for that we will be using these bioamplifiers. Okay, bioamplifiers is an electronic device that can increase the power of the signal. As I said earlier, power of the signal, that is amplitude and the quality. Okay, now why do we go for bioamplifiers? Okay, why do we go for bioamplifiers? Actually, the term here, it is represented as bioamplifiers, but actually the circuit that we are using is amplifier using operational amplifiers. Okay, using op-amp, amplifiers using op-amp. Since it is used in biomedical instrumentation, it is termed as bioamplifiers. That's all, very simple. So biosignals having very low level amplitude and low frequency, and in order to boost the same thing, in order to boost the amplitude level, the biosignals these bioamplifiers are utilized. Okay, then need for low noise bioamplifiers. What is this low noise? First of all, we should know why should we go for this low noise, because our biopotential is already very low voltage. Okay, and the frequency is from hertz to megahertz. Okay, from hertz to megahertz. The bandwidth is very, very wide. Okay, so our bioamplifier must be trained to take these biosignals alone, not the noises. Okay, these noises will be present along with the biosignals, and our bioamplifier should be very high enough to pick the biosignals. That is why we need low noise bioamplifiers. Okay, so some of the features are there. The gain of the amplifier should not be more than 100 dB. Okay, and it should be sorry, it should have low frequency response of the particular biosignal. That is what I said. It should have the capability of identifying the biosignals, and it should differentiate the biosignals and noise. Next one, the gain and high frequency response should be uniform throughout the required bandwidth. Okay, throughout the required bandwidth, and there is no drift of the amplifiers. Okay, drift in the sense it should not get, the output value should not get gradually get reduced. Okay, gradually get reduced. How it is gradually get reduced? It is due to some external influences. For example, the body motion, temperature, and interference of EMI waves also. Okay, and the output impedance of the amplifier should be very small. Okay, then common mode ratio. The common mode ratio should not be more than 80 dB. Okay, in order to eliminate the power frequency interference 50 Hertz. That is very, very important. Okay, if it is less than 80 dB, then this power line interference, that is 50 Hertz, may also create some interference in the output signal. That is why it should be more than 80 dB. Then the gain of the amplifier should be correctly calibrated. Okay, that is what we discussed in the second unit. The calibration must be done after every patient. Okay, then isolation. Coming to isolation, it is very, very important. Okay, excuse me. The voltage. Okay, the voltage that is produced as a biopotential should not interfere with the power line. Power line in the sense it can be AC or DC. Okay, and even some other noises. Okay, so for that we should have some isolation. Isolation can be done in 3 different methods: transformer isolation, capacitive isolation, and finally optical isolation. Everything we will be discussing in the last portion.